you, Dragos. Thank you, everyone, for attending tonight. It's amazing to see such a great crowd and everyone taking time out of their busy schedule for this. So what I'll talk to you about is actually executing on data science projects or machine learning projects that you might have in your organization. As I mentioned, I'm Sabina, and here's my email if you want to get in touch with me. So everyone has ideas, and ideas are great, but executing these ideas is a completely different thing. And what I want to talk to you about today is not just thinking about those bleeding edge algorithms and what they mean and how cool they are, but actually even getting something simple into production or into your product, which is actually quite complicated and takes a lot of work. So what I'll take you through is how to actually map your data science work with your business needs. So that's a very important part in how you get started. I'll talk about how you can start prototyping and matching your prototypes with KPIs that matter to the business. We'll talk about deployment methods and how to build pipelines to suit your business needs and closing that feedback loop. So everyone wants to do innovative work. Maybe some of us like to work in the ivory tower, but most of us want to make a difference with our work. And we want to make a difference in terms of the business that we work for. And that's usually somehow affecting the bottom line. But we also want to do cool work. We don't want to spend time creating reports or just providing proof for things. So what we'll go through are some of the first few steps that you can take to actually go from having nothing to having something in production or deploying some sort of data science or machine learning in your organization. I'll only focus on the first 3 phases here, which is figuring out if it's the right time to build machine learning in your organization, how to build and deploy your pipeline, and how to iterate over that pipeline. We won't talk about refinement at this stage. Okay, so step 1, or phase 0, is how to determine whether it's the right time to build machine learning for your system. So you're probably all from different organizations, different verticals, industries. There are a lot of use cases. And the first step is always use case, use case, use case. If you don't have a reason to be doing machine learning, then maybe you shouldn't be doing it. So how you actually do machine learning will depend on what you're trying to do. Whether you're in manufacturing and want to do some IoT work, whether you're in e-commerce and you want to actually figure out who you should target and what offer you should give them. These different use cases will drive how you approach the problem. In addition, the different use cases will also have different costs associated with them in terms of the infrastructure that you need to build. So if you're looking at IoT, well, you're going to need sensors installed all over the factory floor. You're going to have to ensure that the data from those sensors flow into your systems, and you store that data. And you need to be able to analyze that data and be able to push those results back to your systems on the factory floor. If you're doing something like targeting customers for a marketing campaign, maybe all you need is a CSV file with emails that you give to your marketing team. So that requires a completely different type of investment, or maybe not so much investment. So for each use case, you might have different KPIs that you want to monitor. And these are important because this is what you need to be able to measure at the end of the day to make sure that your machine learning is actually making an impact on your business. So whether you're trying to get in new business, so convert your customers, increase their basket sizes, whether you're trying to save money for your organization, things like fraud prevention or detection, or you're trying to optimize your business. So there are different KPIs that you'll need to figure out before you actually get started on the data work. So here's an example. So we want to integrate these KPIs that we have with the models that we actually build. So let's take fraud as an example, credit card fraud. So as a credit card company, what you want to do is identify fraudulent transactions. But you're not just worried about identifying fraudulent transactions, you want to catch especially large transactions as an example. Because if you let those slip through, that's a huge cost to your company. And you might also have a human cost, a call center cost associated with fraud. So the more transactions that you label as potential fraud, the more activity you're actually going to have for your fraud analysts that have to manually review, for example, a specific transaction. So you might want to also reduce the load on your analyst team that has to manually review these transactions. So you might have a variety of KPIs and different weights for these KPIs and how much they matter to your business. So let's continue with that example. And let's say you hire a data scientist and say, build me a model that identifies fraud. And let's say you're going about it in more of an, from a statistical point of view and say, okay, let's build model number 1. And this is a confusion matrix that let's, for simplicity's sake, just focus on the accuracy. So let's say, okay, model 1 has 76% accuracy. Model 2 has 94% accuracy. So maybe at first glance we'll say, oh, great, we have model 2, this is going to be great, let's put it in production. So this is where things might start to go wrong. So if we look at model 2, and highlighted in red is the false negatives. So these were predicted to not be fraudulent, but actually were fraudulent. So there are very few false negatives in this example, but let's say there are very large transactions. So what happened with this model is you missed large transactions that cost the company a lot of money. So in terms of the KPIs, actually this model is not that great. However, this model reduced the amount of false positives. So in this case, maybe you reduce the amount of time that your agents took on getting to the day's transactions, but you know, which one's better, you'd have to figure out on the business, based on the business and the dollar amount and what you're saving and what you're spending. So just to illustrate that statistical accuracy or ROC or AUC or other model evaluation methods will not be enough to figure out what's best for your business and your application. So yeah, what we want to do is make sure that our model objectives take into account our KPIs and what we want to actually achieve with this exercise. So once we have our business objectives, this will actually drive our requirements, we have our use cases, and we'll need to get the right data to actually be able to answer these questions. The next step is to actually start prototyping. You want to be able to show value with your first few prototypes. You'll take a first pass at the data, prototype the model, and map those KPIs with the outputs of your model. And ideally, if you're not familiar with the data and you have a larger team that's familiar with it, check the results with subject matter experts. So here's an example. We'd want to create a simple model on some sample data, and it doesn't matter if it's not the most advanced model, but you want to test that model on another sample, such as an out-of-time sample, and again, align it with your KPI. So if we take the fraud example again, we'll see here that we have the fraud caught by decile. So the top 3 deciles, or the top 30% most likely to be fraudulent transactions, are catching, let's say, 80% of the total fraud dollars. So this is good, and this model is actually showing value for the organization. So once you have that prototype and that first model, wrong direction, you want to go ahead and deploy that model. So what does model deployment mean? Simply put, make those model outputs available for decision making and typically apply it on new data. So you've probably heard about words such as batch and real-time thrown around. Those are some deployment methods that organizations will use. So we'll talk about different options here. So batch is one of the more simpler methods to do infrastructure-wise, and the complexity in infrastructure and the cost goes up as you implement different kinds of going from batch to real-time. So let's start with batch. Like I said, let's say you have a Jupyter notebook on your computer, you run a Python script, you get a list of customers that you want to target, you have their email addresses, you do that once, it's a one-off, it's error-prone, but it's very little cost. And you can make a file available to the marketing team so they can send emails or create a campaign on Facebook for your offer. So very little infrastructure complexity, little cost, potentially error, but it's a good first step in getting started. Next step is increasing in complexity. You can have a batch process, like a model running somewhere, and you can have that model actually dumping model results into a database. And this is done in batch also, and you can schedule these jobs every time you get new data, let's say once a day. You can rescore that data, have your model outputs there, and they can be accessed in batch. You can combine batch and real time in a database, for example, where a model is scored in batch and you have different results stored in there, but it's accessed in real time. And then you can have everything just in real time, where the model lives somewhere in the cloud. Every time you get new data, it gets automatically scored. Okay, so we'll go into actual examples with that, with building and deploying that first pipeline. But before we get started is, when you think about this pipeline, whether you're doing batch or real time and how you're combining the two, you need to think about the business. You need to think, where is this model going to be deployed? Again, is it batch or real time? Don't just do real time because it sounds cool. Do it if you need to. Think about the infrastructure that's needed to support whatever method you choose, and figure out what teams need to be involved. Usually IT ops, dev ops, engineers, etc. will have to be part of this, especially as the complexity increases. So here's one example, simple batch example. So what we have here is, let's say, an application such as an e-commerce website. This application generates data. Let's say you have users coming to your website, they make a purchase, we store that session and purchase information into a database. That historical data is used to create a machine learning model. You use that model to generate predictions. You create, let's say, an output like a CSV file, and you hand that over to marketing. Marketing sends their email, everything's good, everyone's happy, we have something. So that's valuable in itself, but again, it's error prone. There's a lot of room for human error in this case, but it doesn't require a lot of investment to get it going. If we look at the database example, it gets a little bit more complex. Usually engineering will be involved in this one. Again, we have our application, the data is stored and it's processed in batch. These predictions are created and let's say they're stored in a database. Usually engineering or data engineering or IT ops maintain these databases. There's usually a distinction between development and production and how they like to manage that. But basically, you can store your predictions in batch in this database. The engineering team will make them available, for example, in real time in the application. So let's say you score your customers monthly or daily, but whenever that customer arrives at your website, in real time, you ask the database for the information on that customer. Anyone can be given access to this database, so the marketing team in this example would still have access to the same data as before, but they would be accessing a database rather than a CSV file. There's also a very important point here on a feedback loop. So the feedback loop is essentially, you have a certain prediction, you have the actual outcome, so in order to do a better job next time, you want to capture whether or not your model was correct and evaluate the performance of your model. I'll talk a little bit more about monitoring and A/B testing later on. And finally, we get to a combination of batch and real time. So we have the application again here. We're storing the data in the application, in the database historically, and we create a model in batch. However, you'll notice that there's a handoff of that model between the batch process and real-time process. So at my previous job at Points, this is what we did, is I created a model and I handed it off to the engineering team, and they put it up in the application itself, which they managed. So we needed a good handoff and sort of handshake system and process around that to make sure that what I do and what they get and how we actually score it is consistent and doesn't break anywhere in the pipeline. But let's say engineering has this model, they put in the application, The application in real time gets data from what's happening on the application in that moment, scores it, and returns a response in real time back to the application. So it's a combination of batch and real time, because some things can't be calculated in real time, or they can, but they're very expensive computationally. So you have to think about, do I want my users to wait 30 plus seconds for a response? And usually the answer is no. Now, in terms of some tools, these are just some examples. When I was at Points, we actually implemented PMML. So this is something that works with scikit-learn, but it's built with a Java engine, so JPMML. We also used Flask to create microservices. Also works really well with Python in general. If you're using Spark, there's something called mleap that's available for Spark. In terms of some considerations, again, you need to think about your business needs. Do you need to make a decision in real time? You need to work with IT on architecture and infrastructure costs and figure out how and where engineering is involved, because of that seamless handshake has to be seamless. And the last step that we'll talk about today is iterating on that pipeline. So I love this slide because everyone talks about machine learning and how glamorous and fun it is, and it's true, it is really fun. However, it's only a tiny, tiny box compared to everything else that you need to do to make that work. So I've touched on a few things, but there are some points that I want to make about data, feature extraction, process management, and monitoring. So some considerations for data. Again, let's say your data science team is building models, and you have this process where you hand off your models to an engineering team. So whatever features you use to create your model need to be exactly the same features that you can calculate when the model is deployed. So if your engineers have a different idea of what a business traveler is and how you calculate that, you're going to fail horribly. This almost happened, and luckily I caught it really quickly. We had exactly that, a feature called business traveler. It was a flag of 0 or 1. And we realized that we should be calculating it in a different way based on the behavior on our website. But we've been doing it one way for a year and a half. And one of the engineers said, I'm just going to change the calculation. Is that okay? Like, I'll just change it. I can have it done by tomorrow. It's like, no, you're not overwriting that calculation. We need to create a new field called Business Traveler 2 or something, because you're going to invalidate all of my models from the past, and their behavior is going to change. So you need to have really good communication as well when working with the different teams and how the data flows through the system. As I've said, features can be calculated in batch or in real time. So even if you have real time, you can calculate things every couple of hours and make them available in real time. And you have to come up with a process, as I've said, for creating new features, how you communicate that through your system and have everyone on board and have everyone be responsible for their piece so that the pipeline doesn't break. Some process around deployment. Again, handoffs are very important. So communication and making sure that all the teams are aligned on who's responsible for what. Process tools, Jira is a popular choice where there are multiple sign-offs before something can go into production, and there's pre- and post-deployment testing. Tracking data changes, as I've mentioned, is also super important, and making sure you don't break the pipeline. And it's true, I've had models explode in production, which is why I'm going to go to the next part of my talk, which is closing that feedback loop to make sure that if your models do explode in production, you know and you can take them down. So closing the feedback loop, super important. The method that I advocate for is the champion-challenger method. So essentially you want to have more than one model or more than one thing in production at a time. It could be business rules versus a model, it could be model versus model, it could be 5 models, whatever. But you need to be able to push more than one thing into production. let's say you have one that you know works and one that's your model, and you want to make sure that you capture the data and the performance of those models. If you can do it in near real time, it's great, because if something goes wrong, you'll know quickly. So monitoring is super important. You want to look at the KPIs. So even, as I mentioned, if it's a good model statistically, maybe you lost something along the way around KPIs. If your KPIs are plummeting when you launch a model, that's a bad sign. Like I said, that's happened to me. So you have to make sure you track the correct KPIs when you launch a model. So again, for the fraud example, if you monitor predicted fraud versus actual fraud, I know this as a real example takes a while to make sure that something was actually fraud and label it as such, and monitor the fraud dollars caught, for example. And part of that monitoring is A/B testing. So as I mentioned, having a way to see which model does better, having that infrastructure that will allow you to have more models and more than just one model in production, tracking them, monitoring them, and ability to test for significance and performance. So, okay, we're making more money per customer with this model, but is that statistically significant? There are many methods to do this. You can do something like A/B testing. You can have multi-arm bandit, which is an entirely different topic that I could potentially speak at a later time. But this is also important to continuously improve on how your models are doing. So I have some closing thoughts. So building the correct infrastructure that allows for model deployment takes a lot of iteration and a long time. The first time I went from nothing to something, a project where we implemented real-time scoring in a product that had no machine learning whatsoever, took over a year. And there are lots of bugs. There are bugs all the time. Bugs in the data, bugs in how it's calculated, how it's stored, what it means, the model, even doubts on whether you have the right data to answer the question. So there will be lots of bugs. Data scientists always will need data engineers and software engineer counterparts. I think of it as a holy trinity of data science, data engineering, and software engineering. It's like the perfect mix. Data science can't exist in a vacuum. And last but not least, failure is good because you learn from it. Don't worry if your model explodes. Hopefully you can just turn it off and learn from it. Thank you.